So good morning everyone. So let us start the class. In the last class, I have told you all to do a numerical, right? Were you able to do that numerical? Were you able to do that numerical in the last class, students? Hello, hello, hello,
Oh,
hello.
we
Am I
can
not
hear you,
audible to all
sir.
of you? Yeah.
Yes, audible, sir.
Please reply to me, okay? If I am audible.
Yes, sir.
Okay, someone is telling me I am audible. Okay, okay, fine. So now, uh, the last class, you all did the numerical, right? So in that numerical, you all had to solve and find out the using the equations m1 v1 and m2 v2. M1 v1 and m2 v2, these are the two equations which are very important while finding out the conservation of momentum, right? So was it clear for all of you? Can you just tell me if you have any doubt? You can ask me. Can you see my screen? I'm sharing my screen.
No, sir, nothing. We can see nothing.
Hello. Can you all see my screen?
Yes, sir.
Now
Yes,
can you
sir.
see?
Yes, sir. Example.
I'm not able to hear anyone's voice.
Yes, sir, we can
Or
see.
can you see the screen now?
Yes, sir.
Hey, mother. Hello. Yeah. Okay.
Yes, sir.
So now let us start with this. Now here, if you see, a ball impinges directly on a similar ball at rest. The first ball is reduced to rest by the impact. Find the coefficient of restitution of the half. The half of the kinetic energy is lost by impact. Now in this numerical, what we did was, first of all, you have to find out the initial velocity of the second body, u2, because it is zero because it is at rest, and then you have to find out the final velocity of the first body, which is equal to 0. Okay. Students, can you someone please speak up something? I can't just hear anyone's voice.
Hello, sir. Can you hear me? Hello.
Another, I'm not able to hear your voice.
Okay,
Hello?
sir.
Hello? You can hear me? Okay, fine. Then listen to me.
Yes, sir.
So now what happens here? Just type in the chat box for any problem. So now, as per the question, it is given that initial velocity of the second body u2 is equal to 0. Why it is 0? Because it is at rest. Look at the question first. Huh? Let me explain this numerical to you. So, because look, a ball impinges directly on a similar ball at rest. So, the first ball is reduced to rest by the impact. Now, you have to find out what the coefficient of restitution. Now, here, if you see, first of all, the first ball is reduced to rest by the impact. That means what? The first one ball is hitting the other ball, right? So if the one ball is hitting the other ball, then what happens? Then the first ball, that means the ball which is hitting it, reduced to rest. Now you can find out the coefficient of restitution if half of the initial kinetic energy is lost by the impact. Now if you can see from here, what happens is that now one ball hits the other ball, huh, at rest. That means what? The U1 is the initial velocity of the first body. Now it has got some value. Now u2 is equal to 0. Why 0? Because it is given now it is at rest. Now after that what happens? The v1 becomes 0. Why v1 becomes 0? Because the final velocity of the body is equal to 0. And the other body which was at rest initially comes to motion. Right? So now we have to find out in that order. After that, if you see, first of all, for a given initial displacement, okay. So now after that, let us find out. Assume that the mass of the first body is equal to Amazon. Then last mass of the first body is m1. Now m2 is the mass of the second body. Okay, so m2 is the mass of the second body. U1 is the initial velocity of the first body, and v2 is the final body velocity of the second body. Now E is what? The coefficient of restitution. Okay, so now you can find it out how. It is like kinetic energy of the system before impact. Now suppose there is one impact. So what is the kinetic energy of the system before impact? That means what? Suppose uh, one body is what? One body is striking with the other body, right? So if one body is striking with the other body, then what happens? Like there will be one impact, no? So if there will be one impact, then if there will be one impact, then definitely before the impact there will be one equation, and after the impact there will be another equation. So we'll have to find out those equations. Now if you see the first equation, wait, marking it too. Students, just write in the chat box, okay, if you have any problem. Maybe if you can see in this equation, This is equation number 1. Now in this equation what happens? In this equation your the kinetic energy of the system just before the impact. Huh? So this is the first equation. Okay. So if this is the first equation, then before impact, huh? And there is one on after impact, right? Now before impact what happens? Before impact the velocities will be initial velocities, right? So if the velocities will be initial velocities, then what happens? Then your there will be u1 and u2. Why u1 and u2? u1 and u2 are the what? Initial velocities, right? So u1 and u2 are the initial velocities. That is why we are having two velocities for the case before impact. So that is why we are getting what? Half m1 u1 square plus half m2 u2 square. Okay. So now if it is half m1 u1 square plus half m2 u2 square, then what happens? m1, you know, u1, you all know it is having some velocity. That is why we are keeping it as u1. Now u2 is what? u2 is 0, as you know, because the second body was at rest initially, no? From this part. From this part, the second body was at rest, no? From this part, right? है ना? तो अगर ये second body rest पे है, हाँ, so that is why we are getting this equation. Yes or no? That is why we are getting this equation. That means what? We are getting half of m1 u1 squared. Now after that, if you see, after that if you see, for the final part now, we are done with the initial part. Now for the final part, what will happen? It is after impact. It is what? After impact, the first one becomes 0 as per given in the question. But the second one will now attain some velocity. That is why we are writing these two equations, but then this one and this one will come out to be like this. So this one and this one will come out to be like this. That means why? The V2 will be what? 0. V2 will be 0 because of this region. That means, what do you call it? The V2 will be not 0, sorry. The V2 will have some values, but V1 will be 0. Okay? Because the first one will come to rest, then second one will have certain amount of movement and all. So in this way, you can write now. Now, in the previous classes, we discussed about loss of kinetic energy due to impact. Yeah, so what is that thing actually? Now, loss of kinetic energy due to impact means, uh, students, you are following me now? Just write in the chat box. What I am telling you can hear me clearly now. Yeah, Maro, Kabam, you just ask in the chat box.
Yes.
Maybe I am having some issues. Hello, Kabam, Maro. Someone raised their hand just now. My voice is low. Now is it low? Is it low now? Is it low now? Hello, is it low now? My voice is again low. Someone please write in the chat box. Is my voice again low now? Hello. Oh, sorry. Okay. Okay. So can you speak up now? Can you hear me now? So can you hear me now? Okay, you can speak up. Someone please speak up. I can, if I can hear it or not. Someone
Yes,
please unmute and
sir.
speak
Yes,
up.
sir. Can you hear me, sir?
Yes, sir. We can hear it, sir.
No? Okay. Fine. Leave it. Just share to my voice. and write in the chat box. Okay, just hear to my voice and write in the chat box. Okay. Can you all hear me now?
Yes, sir, we can hear it.
Okay, okay. Now I can also hear you. Okay, thank you. There were some issues with the settings. Okay, so let us continue. Whatever others, can you all hear me?
Sir.
Okay, okay, okay. Before also you could hear me now, but I could not. I just saw the chats. पहले भी तुम लोग को सुनाई दे रहा था मैं जो 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 एक्सप्लेन कर रहा था तुम लोगों को.
Yes, sir.
अच्छा ठीक है तो थैंक यू. Okay then we just continue now. So we know that kinetic energy of the system before impact. So before impact it was in that manner. Now after impact it is a bit different. So after impact what happens? So after impact it is m1 v1 square plus half m2 v2 square. That means what? It is. Hello, am I audible, students?
Yes, sir.
Okay. If voice is low, then write in the chat box. Huh? So now after that, what happens? The kinetic energy of the system after impact. That means what? Suppose when the first body strikes the second body, ah, there will be one impact, no? So there will be one impact means what? Suppose someone is. Suppose I get an example of the car now, the previous classes. Suppose one car is hitting the other car, the second car is stationary. What happens? A car which is moving, it will eventually come to rest, but then a car which is stationary, it will start moving because of that impact. That is what this basically explains. So don't get confused about this U1, which one will be 0, then U2 will be 0. Okay, now what happens? Let us see loss of kinetic energy. What is the loss? Suppose one body is in, suppose one, what do you call it, one object is in the other object. If one object is hitting the other object, then after that, what happens? There will be one loss in the energy. So what will be that loss? So basically that loss just that is the difference. Okay? It will be the difference. That is why we are writing it. Why we are writing it as EL equal to U1 minus E2. Okay? So U1 minus E2. Is it okay now? Is
Yes,
it
sir.
okay? Okay. So U1 minus E2. What does U1 minus E2 means actually? E1 minus E2 means the difference between the energy or the kinetic energy of both the systems, right? So the difference will be found out in this manner: half m1 e1 square minus half m1 v2 square. Okay, so this will be the what? Loss, or loss in kinetic energy because of that impact. So now you just put this equation in this manner. So after finding out the loss, you just find out in this manner. Now in the question it is given half of the initial kinetic energy is equal to loss of kinetic energy by the impact. So you can find it out from here. Look, the first ball is reduced to rest by the impact, and from this here find the coefficient of restoration if half of the initial kinetic energy is lost by the impact. That is why we wrote it is like this. So since half of the initial kinetic energy is this one by the impact, therefore half of m1 e1 square. Why half of m1 e1 square? Because this is the initial kinetic energy, na? So this is what? Half of m1 e1 square equal to what? Half of m1 e1 square minus half of m1 v2 square. Okay, so these two will be in that manner. Now you just compute these two equations, you will get like this. Okay, v1 square equal to 2v2 square. So this is simple mathematics. This part is what? Simple mathematics. This part is simple mathematics means what? You have to find out this one like this and like this. Now after you found out these equations, that means the relationship between u1 and v2, you can just write in this manner the law of conservation of elastic bodies. Yeah, someone asked me a doubt. Can you please pick up? Someone asked me a doubt. Can you please pick up? If someone asked me a doubt, can you please pick up?
Sir, kinetic energy after the impact.
ना कौन सा part?
That answer is kinetic energy after the impact. उसका आंसर में सर m1 v2 स्क्वायर दिया हुआ है, लेकिन v1 का वैल्यू जो 0 था तो m2 होगा नहीं सर, उसमें m1 लिखा हुआ है आंसर.
हाँ 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 हाँ, रुको रुको, ये वाला देखो तुम, ये वाला स्टेटमेंट पढ़ो.
Yes.
देखो क्वेश्चन पे दिया क्या है, यहाँ पे तो कुछ नहीं दिया गया है बॉल का. दिखा सिमिलर बॉल दिया गया है कि नहीं, है कि नहीं?
जी सर.
तो अगर एक
जी
दोनों
सर.
दोनों बॉल सिमिलर है तो हम लोग ऐसा लिख सकता है ना, यू कैन राइट लाइक दिस ना, m2 इक्वल टू m1. दैट इज व्हाई आई एम नॉट टेलिंग अबाउट इट. समझ लिया? इसलिए वी हैव टेकन इट एज डायरेक्टली m1. नाउ डिड यू अंडरस्टैंड?
Yes sir.
Okay, good. So now let us continue to the next part. So now after that what happens, you found out the relationship between this one, we found out the relationship between this. Then look, law of conservation of elastic bodies. Law of conservation of elastic bodies, this is the statement ना, v2 minus v1 equal to e u1 minus u2, है कि नहीं? तो अगर this is the statement, then v1 is what? Then v1 is equal to 0, right? and u2 is equal to also 0. Now if u1 and u2 is equal to 0, then v2 minus 0 equal to u1 minus 0. That means what? v2 equal to u1. Now these two equations, if you this equation and this equation, if you compare these two equations, then you will get this relationship, and eventually you will get this equal to 0.707. So is it okay now? How you find out? Is it okay now? How you find out? Students, is it okay now? Okay. Okay. So I think this numerical is clear for everyone.
Yes, sir, it's okay.
Okay. So we'll do another numerical of the same pattern. I'll ask you to do now. We'll have to do it now. And after that, in the next class, we'll be discussing the answers like today. Okay. Can you all see the screen? Okay then. Try to do the numerical. So in this numerical, it is given what? Mass of the sphere is 1 kg. It is moving at 3 meter per second. Now it overtakes another sphere of mass 5 kg, which is moving at the same line at 60 centimeter per second. Now you have to convert this centimeter per second to meter per second first of all. Okay. Then you have to find out the loss of kinetic energy during impact. So first of all, you have to m1 is 1 kg and m2 is 5 kg. Okay. Now there is u1 values, and you have to assume the rest things and just try to do it. Okay. Try to do it. Students, do I need to give you some hints? Students, do I need to give you some hints? Okay. So listen. You can see that numerical question now, right, in the screen. Can you all see that? Okay. So now in that question it is given what? The mass of the first sphere m1 is what? 1 kg, no? So now initial velocity is what? 3 meter per second. Now the mass of the second sphere, that means m2 is equal to what? 5 kg. Okay. Oh, m1 is 1 kg, m2 is 5 kg. Now initial velocity of the first sphere, that means u1. u1 will be what? 3 meter per second. Now, and the u2 will be what? Given 60 centimeter per second. Now look, 100 centimeter equal to 1 meter. So 60 centimeter equal to how much meter? Tell me. Someone tell me 60 centimeter equal to how much meter?
0.6.
Yeah. So it will be, what will be the, then what will be the initial velocity of the second sphere then?
Zero point 0.06
Not 0.0.
meter per
It is 0.
0.6.
It is 0.6 only. Now look, we have to find out the loss of kinetic energy during the impact. Now the loss of kinetic energy during the impact, there is one formula. So loss of kinetic energy during an impact, there will be one formula. So which formula you will be using it for it? Wait, I'll tell you. You have to use this formula. So this is the formula for loss of kinetic energy during impact. This formula is basically derived from the previous equations only. So as to make your things more simpler, so this formula has been derived. From the other equations only it is derived. Now you know m1 and m2 and u1 and u2, and e also you know 0.75. So can you find out the loss of kinetic energy during impact, students?
Yes.
Okay. So once you are done finding out the loss of kinetic energy during impact, you can take a screenshot of this. Okay. So once you are done, then you have to do for the second part. So how will you do the second part? You have to give the equation. From conservation of momentum equation, you get m1 u1 plus m2 u2 equal to m1 v1 plus m2 v2. Now you know m1 and m2, and u1 and u2 also you know, but you don't know v1 and v2, right? So you will be getting an equation in terms of that, and also there will be another equation on the basis of the law of collision of elastic bodies. That means that equation will be what? v2 minus v1 equal to e u1 minus u2. So here also you know certain parameters. So you will be getting two unknowns and two different equations. So from that unknowns you have to find out the v1 and v2. Okay. And then if one comes up to be negative, then you will be knowing that the direction of motion of the first body is reversed. Can you guys try it out?
Sir, can you explain again the second part?
In the second part, you will be getting two.
After
Listen, in the second part, you will be getting two equations. First equation is what? First equation is from the conservation of momentum. So conservation of momentum means what? m1 u1 plus m2 u2 equal to m1 v1 plus m2 v2. Yes or no? first part, that one, and
Yes, sir.
you have to use the relation v1 minus v2 equal to v2 v2 minus v1 equal to e u1 minus u2. So you will be using those two equations, then you will be getting, you have two unknowns now, you don't know the final length velocity, so you don't know the values of v1 and v2. So you have two unknowns. So if you have two unknowns, then from those two equations you will be able to find out the v1 and v2 and finally prove that what is given in the question. If you don't, if you are not able to do, we can I'll solve it in the next class, but we have to try it. Will you try it?
Yes.
Okay. Okay. So try it out. You just take a screenshot of the question. Have you taken this question screenshot, students? Okay. And try solving it out. First part you can find out using this identity, using this equation EL. हाँ ये इक्वेशन इसके के फर्स्ट पार्ट तो निकाल लेना चाहिए तुम लोग को सबको. मैं सेकंड पार्ट एक्सप्लेन करूंगा इफ इट इज नेसेसरी, बट देन फर्स्ट पार्ट तुम लोग को निकाल लेना पड़ेगा खुद. If you have any doubt, you can ask me. बोलो.
तो काफी
तुम्हारा वॉइस क्लियर नहीं आ रहा है, बोलो. हाँ बोलो. आई एम नॉट एबल टू. तुम्हारा वॉइस क्लियर नहीं आ रहा है.